All right, welcome back to the NIH Library Bibliometric Training Series. My name is Chris Belter, and I'll be your instructor for this particular session. So with this session, we're really going to be picking up where the last session ended. So we're going to be picking up about how to actually visualize networks that you created. So last week, we talked all about how to create collaboration networks using the Science of Science tool. In this session, we're going to be picking that up, and we're going to go into the actual visualization process. To do that, we're going to be using an open source tool called Gephi. This is actually a tool that's developed by some folks in France to do all kinds of generic network visualization tasks. It's used primarily in the social sciences, but it's gaining traction in a lot of other areas as well, because it gives you a lot of control over what your visualizations end up looking like. You have a lot of control over the sizing, the coloring, the layouts, all sorts of things like that. And so it gives you this very fine, detailed control over those visualizations. So while it may be a little bit more difficult to learn, so like Sci2, there's a bit of a learning curve involved in learning how to use it, but the benefit for that higher learning curve is you've got more control over the actual final visualizations. So harder to learn, but gives you more power and more control over what you're doing. A couple of notes about Gephi, just as we're sort of getting started here. Once again, it is a free and open source software tool. You can download it directly from Gephi.org. Gephi does also have a number of quick start tutorials that have been developed both by the developers of the tool as well as by a very active user group. So Gephi is one of those tools that has a lot of people using it. So unlike Sci2, there's a lot more resources for learning how to use this particular tool around online. So in addition to the ones that are the tutorials that are available on the Gephi.org site, there are a number of other tutorials on SlideShare. There are a number of YouTube videos. There's a lot of documentation around this particular tool. So definitely poke around and look around for other resources. I will mention, though, that a number of these tutorials are out of date. So in the past year to a year and a half, Gephi's made a number of improvements and interface changes to one particular part of the interface. So some of those tutorials may be out of date. They may not be using the current version of the interface, so just be aware of that. And I'll point out the particular part of the interface that's changed when we actually get there, so you know what the difference is going to be. A lot of the tutorials are still current. A lot of the applications and the processes are the same. It's just that one piece is really different now than it used to be. So I will, again, point that out when we actually get there. In terms of actually doing visualization steps in Gephi, this is the generic workflow. So most networks are going to follow some variation of this basic process. So you're going to load data into the tool first. You're going to then apply a layout algorithm to actually arrange the nodes and the edges in a way that actually makes sense visually. You're then going to add a number of attributes to the visualization. So you're going to size nodes and color nodes based on attributes that are present in the network. So if you've got quantitative values, you can make certain nodes larger than others. You can color code them by qualitative variables, those kinds of things. Once you've done all of that, you then want to sort of adjust your layout a little bit, because sometimes within that sizing and coloring nodes, you need to tweak the layout a little bit to get it to work correctly. So then you'll sort of adjust it, and then you set your final visualization settings as a separate step. This is kind of one of those weird things about Gephi where you sort of have to do the same thing twice. It's just a part of working with the tool. You just have to. And then finally, you can then go ahead and export your visualization in a variety of file formats. So again, nearly all of the networks that you create and that you go to visualize are going to run through some variation of this process. In some cases, you're going to spend more time doing certain steps than others. In some cases, there are going to be additional steps that you might want to add in to customize your layout, other things like that. But this is the basic workflow that you're going to be looking at and working with in the tool. So with that, let's go ahead and jump into the live demo. So, as I mentioned, we're going to pick up out where we left off in the previous session. So in the previous session, we created a variety of these networks. And so we saved them as .gephi files. Most of the time when you're actually working in the Science of Science tool, you're going to go directly from the network that you create in Sci2 directly into Gephi, rather than sort of saving it and coming back. But in this case, I'll show you how to actually save it and come back and work with it that way. So again, I've got my individual collaboration network and my institutional collaboration network. And if we have time, I'll give you a quick overview of how to visualize both of those networks. For right now, though, let's go ahead and load some of these networks into the tool. So we're going to go back to the Science of Science tool, and we're going to click on File, and we're going to click on Load just like we loaded a .isi file or a CSV file. So we're now going to navigate to where that file is located on our computer. And we're going to select the particular GraphML file that we're going to load. So in this case, we're going to load the individual co-authorship network. So when I click on Open, it will go ahead and import that directly. And up here in the Data Manager, you can see now we have this network file available to us to do things with. This is just like having a network file that we created from a basic CSV file. We can run any additional algorithms that we want to do on it or anything else like that. In the interest of time, I'm also just going to go ahead and load the other GraphML file. So I'm going to just go, again, File Load, and then I'm going to load the institutional collaboration network. You might be calling them different things, but this is just my sort of naming convention for these things. So I'm going to open that. And so now I've got these two GraphML files or network-based files that I can work with in Gephi. So again, I'm going to select the first one that I loaded because I want to start with the individual level co-authorship network. So again, make sure that's selected in the Data Manager. And then when you go to Visualization, Networks, and then Gephi, it will load this particular GraphML file directly into Gephi. The other way to do this is if you want to load a file directly into Gephi without sort of using Sci2, there is a way to do that also. So I'll show that to you once we actually get into the Gephi interface. But for now, I'm just going to go ahead and launch it from the Sci2 tool. So when Gephi first launches, it's going to give you two pop-up boxes. It's going to give you the main Gephi interface, and then it's also going to give you this import report. Most of the time, you can just click on OK and ignore this. But what this is basically doing is it's saying that it's loading a file into Gephi, and it's giving you some details about the kinds of things that it found in that particular network. So if there were any issues in importing this file, they would be listed here. Otherwise, it says no issue found during import. If you're really interested, you can also click over to the tab for the report, which will go through all of the things that it actually found. It says it's an undirected network. It's got column names. It's got node properties. It's got edge properties, blah, blah, blah. Again, most of the time, this is not something you need to worry very much about, but it's in there just in case you want to double check. It will also tell you down here the number of nodes and the number of edges that are present in this particular network, which is often nice to know for sort of context and sort of reporting out. Sometimes that's interesting. And some other things, it also tells you the type of network. It's an undirected network versus directed network, other things like that. Once again, 99% of the time I sort of glance at the number of nodes, the number of edges, and then I just click OK. Because most of the time there's no issue, so I don't have to worry about this. So I'm just going to click on OK. So when you launch Gephi, there are actually 3 different tabs in the interface, and it's going to default to whatever tab you had open when you last had Gephi open. So if it doesn't default to the Overview tab, go ahead and go to the Overview tab first, because that's where you're actually going to work with things. So let me just give you a quick tour of what it is you're actually looking at here in the Gephi interface. This massive blob here in the middle is what your network currently looks like. Whenever you import a network into Gephi, the layout is completely random. So it always looks like this big square with a whole bunch of things and very little sense to it. It's a completely random layout. And again, you don't really have to worry about it because we're going to lay this out. We're going to apply a layout algorithm later to actually make it look meaningful. So for the moment, don't worry about it. It always looks weird. Around this is this graph tab is a preview of what the visualization is going to end up looking like. So again, it has this network that you've just loaded in, and then it also has a number of buttons arranged around the sides of the pane. We'll talk about some of those buttons in a little bit more detail later on, but I just wanted to note that some of them are there, and they give you options for sizing, coloring, adding labels, doing other things like that to the nodes in your network. In the upper right here is the appearance box, and this is the thing that's really changed. So if you go and look at some of those online tutorials, if they're out of date, they're going to be out of date because of this appearance box. They've changed this pretty significantly a number of times in the past couple of years. So this is the thing that's really, really changed. Essentially what it is, though, is it gives you options for applying attributes to your visualization. So it has options for sizing nodes, coloring nodes, sizing edges, and coloring edges based on attributes that you already have in your network. So you can apply just sort of global scale changes to your entire network to be able to sort of size them en masse. Below the appearance box is the layout box. So as I mentioned, when we're actually going to be importing networks into Gephi, it's a completely random layout, so we would need to apply these different layout algorithms to actually make this make sense. So this layout box has a drop-down menu with a number of preset layout algorithms that we can use to actually arrange these nodes and edges in a way that's visually meaningful. In the upper right is a context box. It again just tells you the number of nodes and number of edges and what type of network that you're working with. Again, just so as a reminder of the size and scale of the network that you're working with. Below that is we have actually two tabs related to filters and statistics. Most of the time statistics is the default value, but again, it may go to filters. The statistics tab allows you to run a number of network statistic algorithms on top of the network. So if we're interested in looking at the degree distribution of the network, we can run this algorithm to get the average degree of the nodes in my network. And then again, once again, the degree is just the number of connections from one node to all other nodes. So we can calculate that very, very quickly using some of these statistics options. You also have a range of other options that are sort of more advanced in the network science world. I'm not going to talk about them in a whole lot of detail, but I just wanted to point out that they're there. There are a number of other things that we can do here. There's including a PageRank algorithm, where it's very similar to the Google PageRank algorithm, where it's ranking nodes based on its centrality. That's in here. There are a number of other centrality measures that are buried in here. So there's a lot of things that we can run on this network from that particular tab. The filters tab also allows you to filter the nodes and edges that are visible in the network. So if you'll remember in the last course, we removed edges below a certain threshold. We can actually do that dynamically here in Gephi if we wanted to. So we could actually set a filter to say that we only want to show edges with a weight of 5 or more, or we only want to show nodes with a number of works of 10 or greater, or some other threshold. So we could do that dynamically here in Gephi if we wanted to, but sometimes it's a little bit difficult to set exact thresholds, which is why I tend to do it in Sci2 rather than in Gephi. But again, it is worth noting here that you can do that so that if you wanted to play around with thresholds before you set an exact threshold, you can actually do that using some of these filtering options. Again, I'm not going to really talk about them today, but I wanted to at least mention that they're there. So, as I mentioned, that's a quick overview of the Overview tab. We will get into some of these other tabs, the Data Laboratory and the Preview tab, a little bit later on in the talk. One other thing that I want to mention very quickly is that because your initial layout of your network is completely random, any layout algorithm that you apply actually depends on that initial random layout. So when you try and sort of lay this out in a particular way, it's going to look a little bit different every time you lay it out because the initial import and the initial layout was random. So even if you go back in and try and lay out the exact same data set later on, it's going to look a little bit different. And so if you're following along with this particular graphic and you start applying the same layout algorithms to the same network, your results are going to look slightly different than what mine's going to look like. This is, again, just because of the random layout. The major structure is going to be the same. The major look and feel of the network is going to be the same. It's just certain things are going to be in different places. The sort of take-home message from that is if you want to come back to a network that you have already created later on, you need to save the project rather than trying to save the data set and try and visualize it. Because if you try and re-visualize it, the things are going to be in different places and it's not going to be the same visualization. So to do that, you will want to go up to the File menu up here in the upper left, and you want to click on Save. So you do File, Save, and then again you can save it to a particular folder, but be sure that you want to save it as a particular file type. So you don't want to save it as all files. You want to change it to a .gephi file. So that .gephi file is the file that will actually save all of the work that you've done in a particular project. So it will save the layout, it'll save all of your sizing, it'll save all of your coloring, all of the things that you do in a particular Gephi session will be saved in this .gephi file. So if you need to quit a file and come back to it, work on it later on, or if you need to sort of re-visualize something in a particular network, this is the way to do it rather than trying to re-visualize it from that XML file. So I wanted to just point that out, that that's the way that you will want to do that. Okay. So now what we want to do is, again, we want to start working with that workflow. So the first thing that we want to do is apply some of these layout algorithms to actually make this into something visually more interesting and more meaningful. So we're going to go down to the Layout tab, and we're going to click on the drop-down arrow here, and you can see that there are a number of layout algorithms that are built into the tool. 99% of the time, I will either use Force Atlas or Force Atlas 2. These are actually layout algorithms that were designed by the designer, the coders and developers of the Gephi tool itself. So Gephi is designed to work with these layout algorithms. So the vast majority of the time, I will use one or the other. If you're only ever going to use one of these, use Force Atlas 2. That is the more modern version of this particular algorithm. It scales to just about any size network you happen to be working with. So if you're only ever going to use one layout algorithm, use Force Atlas 2. I mentioned Force Atlas here because in some situations, Force Atlas 2 gets very confused. So if you've got edges with very high edge weights, it's usually a better idea to use the regular Force Atlas algorithm. So if you've got connections between nodes of like 50 or 100 publications, something like that, you're better off using Force Atlas. Otherwise, use Force Atlas 2 for just about everything. So I'm going to use Force Atlas 2. And when you select it, there are a number of ways to modify the actual behavior of the layout algorithm. For now, I'm just going to leave these exactly as they are, but in some cases it can sometimes be interesting to play around with some of the options. But I'm just going to leave this as is, and then I'm going to click on Run to actually apply this layout algorithm. So what it's going to do is it's going to try and push all of the nodes away from that central point. So it's going to try and push all the nodes away from one another, unless they're connected by an edge. And so it uses these edges as essentially springs to make things either larger or closer together or further away. So again, it's going to push everything away, and then if the nodes are connected, it's going to draw them closer together, and the stronger the connection, the closer they are, they're going to be positioned to one another. So this is not an algorithm that will actually stop on its own. You actually have to tell it to stop. It can be sometimes difficult to remember to do that, but you want to remember to, because otherwise you're just going to be running this algorithm and it's going to be taking up memory. So remember to stop it at some point. And you can do that by clicking on the stop button here. I will note that sometimes the stop button does not actually turn into a stop button. Sometimes you can run in the algorithm and it stays the run button, not the actual stop button. It can be somewhat confusing. This is just a bug in the actual interface. So just click on the run button again and it will stop. It's just one of those bugs in the interface. So normally what I will want to do is I'll run it for a couple of seconds, make sure that everything stops moving around, and then go ahead and click on stop once it's sort of figured out what the layout actually looks like. So now what we have is a more meaningful structure. We can start to see patterns emerging. We can start to see groups of nodes that emerge, and groups of collaboration networks, and groups of collaboration links, those kinds of things. And so once again, you're going to see this large cluster, but it may not necessarily be in the bottom right. It may be in the upper left, it may be in the upper right, it may be someplace else, again, because of that original random layout. So you're going to see the same structure, it's just going to be things are in different places. So the next thing that we can do is, once we've got this algorithm, we can also do a couple of things to sort of tweak this a little bit. So we've got, we can also adjust the view by using the mouse wheel. So mouse wheel up to zoom in, and mouse wheel down to zoom out, and then right click and drag to change where the view actually is. So we can get it centered on this particular network so that we can get a sense for what this looks like. You've got a couple of other options as well if you want to tweak this particular layout. So if you wanted to, up here in the upper left, most of the time it defaults to this drag button. So if it's not there, go ahead and click on that, and you can actually then left click on any particular node, and while left click and hold to drag it around, move it in different places. So if you want to adjust things, you can certainly do that. So you can do that either for individual nodes, or you can come back up here to this dragging. Up here at the top, it's kind of hidden in the interface. But if you click on this configure link, you can actually change the diameter of the dragging circle. So if you change that diameter to something larger, it then gives you a gray circle. So if you want to grab a whole set of nodes, you can do that as well. So, you know, maybe up here, I want to drag this particular group of authors a little bit closer in. They don't need to be this far away. So I can just click, hold, and grab the entire group and drag it down a little bit closer. So I can drag entire sets of nodes using this sort of dragging feature. So again, I can maybe want to do the same thing down here, just to bring these things in a little bit. Might do the same thing over here, so on and so forth, to tweak this just to get a configuration that works for the particular view you want to have. And then again, you can change it by going back to the configure and dragging the slide arrow all the way back down, and now you're back to just an individual node. Some other things that we can do with this layout algorithms is we can also rotate the actual view. So if we wanted to change the actual arrangement, we can go back over to the layout box, click on the down arrow, and then we also have an option for rotate. So if we select the rotate algorithm, it will allow us to rotate the entire thing 90 degrees, or we can actually change the angle. So if we only wanted to do it maybe 10 degrees, we can just type in 10 here, hit enter, and then click run, and you can sort of get to a very quick layout of however you want it to be arranged. I will also note that you can actually use a negative value here to rotate it the other direction. So we could also put in -10, and it will rotate it counterclockwise rather than clockwise. So you can kind of play around with it to get it to wherever you want it to be laid out in, and do other things like that. Another layout algorithm that I use pretty frequently is an expansion contraction algorithms. So if we've decided that this network is too close together, the nodes are all too bunched up, we can actually keep this exact layout, but move everything away from one another, just expand the layout a little bit. So to do that, we can again go up to the layout algorithms and select expansion. And if we can set, again, either 1.2 or 1.5, depending on how much you want to expand it, we can run that. And we can just sort of move everything away from one another, or to set it to maybe 0.8 to contract. So we can, again, play around with how sparsely laid out we want this thing to be. So once we've got the initial layout kind of the way that we want it, we then can go in and add some additional attributes to this network to visually represent some of the attributes that are present in our network. So once again, this is a co-authorship network. We've got attributes about the number of works for each author. We've got attributes for the number of co-authored papers between authors. All of those types of attributes that we'd like to visually represent in this particular visualization. So to do all of that, most of the time we're going to be working in the appearance box, but we do have some additional options to size and color individual nodes, which I'll talk about in a little bit. Most of the time, though, we're going to be using the appearance box to do most of this. So the first thing that we're going to do is we're going to apply layouts either to nodes or to edges, and this can get really confusing where you are. So you'll really need to pay attention to what's actually selected up here. So we have options either for nodes or for edges. And when we click either on nodes or edges, very little changes. So it can be very confusing what it is you're trying to actually work on. So it sort of has this depression around whatever thing is actually selected, but it's easy to miss. So, pay attention. But within both nodes and edges, we have options for either color coding the nodes, sizing the nodes, or sizing and coloring the node labels. So within nodes, we have options for doing all of those things. In edges, we have options for coloring edges or coloring labels or sizing labels. I almost never use edge labels, just as a FYI. In some kinds of networks, they can be meaningful, but most of the time in bibliometric networks, they're really not. So really with edges, all we're really doing is color coding them. They're actually already going to be sized by the numeric attributes that are present. So because this was a weighted network, they're already going to size the edges based on that numeric attribute. So it's already going to do that. So the only thing left for us to do is maybe color code them if we want to reinforce those attributes. But again, what I want to start with are the node attributes, and then I'll work with the edge attributes. So with the node attributes, the first thing I'm going to do is I'm actually going to just set them all to a unique color. So rather than having them all be black like they are currently, I'm going to set them to this default gray color. I will note, though, that if you click and hold on this color box, it will actually bring up a selection piece where you can actually drag in and actually change the color. So you can drag it to anywhere in this color palette that comes up and set that as the unique color for all of the nodes in your network. But again, I'm just going to use this default gray color, so I'm just going to click on Apply. So that just sets this unique node color. And so then we can sort of work with other things from there. The next thing I'm going to do is I'm going to size them based on the number of publications that each author has written. You could also size this by the number of times cited if you really wanted to, but for this visualization, I'm going to size them by the number of works. So again, with nodes selected, I'm going to go over here to those circles and click on size. So again, very little changes in this attributes box, so it's very easy to be confused as to what you actually have selected. But again, if I've got this size selected, I have either options to set a unique size or to set a ranking size, or size by ranking, or size by a unique value. So I can, again, with size selected, I'm going to go over to ranking, and then it's going to bring up this drop-down box where I can select what attribute I want to use to size the nodes. So in this case, I want to use this number of authored works attribute to actually size the nodes in my network. So I'm going to select that, and when I do, it brings up a minimum size and a maximum size. Most of the time, I set this at a minimum size of 5 and a maximum size of 50. But in some cases, you might want to set that maximum size all the way up to 100, 150, other attributes or other sizes, depending on what your network looks like and the attributes that are present, other things. But usually 5 to 50 is a good starting point to work with. It seems to give me a pretty good range of sizes, so that's what I typically go with. So to do that, I'm going to go ahead and click on Apply. And so again, it's now sized those nodes in a sort of continuous scale, so it's very, very easy to see the individual nodes that have a very high number of works and the nodes that have a very small number of works. Some other attributes that we can also work with are some of the edge attributes. So again, I wanted to size the nodes based on the number of authored works, and then I want to color code the edges to make the frequent co-occurrence or frequent co-authorship relationships very, very easy to spot. So what I'm going to do is I'm now going to go up to ranking, or I'm going to go up to edges. I'm going to select edges, and it's going to default to color. And so I can color either by unique, partition, or ranking. So partition is their way of saying I want to create a categorical color scheme. So if edges belong to certain categories, I want to partition them and create this color scheme to sort of say some edges belong to one category or other edges belong to a different category. Again, I don't use this very much in edges, but I do use this pretty frequently when I'm color coding nodes. So if nodes belong to certain categories, I'll usually color code them based on those categories. And so again, I can bring up that partition to be able to color code based on attributes that I have in my network. But for this time, I'm going to go ahead and select ranking again. And then again, it's going to give me this drop-down box, so I'm going to select number of co-authored works. So what it's going to bring up is a default gradient from a very light green to a dark green. If you wanted to, you can actually hover over it, and you'll notice that there are these triangles that appear. And so these are the actual sort of stop points within this gradient. If you right-click on any one of these triangles, it brings up a dialog box where you can actually control the actual gradient. So if you wanted to select a darker green, you could click in on this box to select a darker green. Or if you wanted to change to a blue, you could click on the sort of gradient here on the right and then select the particular shade of blue that you wanted to work with. So it, again, allows you very, very detailed control over what this gradient looks like, how it appears, and so forth. For the time being, I'm just going to use the default green color scheme, and then I'm going to click on Apply. So it again very clearly shows where some of these very strong co-authorship networks are, but the downside to this is some of the lighter connections are very, very difficult to see. So with this particular gradient, it's very difficult to see the very light connections. So I would usually want to tweak this to some degree to make those a little bit more visible. A couple of ways of doing that is sort of, again, kind of buried in this interface. To the right of the gradient, there is actually a button that you can click. So if you click on that button, it actually gives you a set of either default gradients to work with or recent gradients that you've used previously. So if you don't like greens, you could go in and set it to a purples color scheme. You could set it from shades of blue. You could do shades of yellow to blue. Some of these other gradients that are sort of built into the software to either use as they are or to tweak using that right click and then tweaking the actual individual points of the gradient within it. So again, you can select one of these and work with it from there. Or what you can also do is you go down to recent, you can see a number of gradients that you've used previously. And so once you get a color gradient that actually works for you, you can just reuse it over and over and over and over and over again. So what you can see is I've actually sort of did a couple of tweaks on this kind of blue gradient to get to a blue gradient that I actually liked. So I used one, tried it out, didn't work so well, tweaked it again, until I got to a blue gradient that I actually liked. And so this is the one that I just use for all of my visualizations moving forward. So I'm going to, for this network, I'm going to select this blue gradient, and I'm going to click on Apply. So again, you can still very clearly see where those very strong relationships are, but the light gradient is a little bit darker, so it's a little bit easier to see those lighter co-authorship network relationships. So some other ways that we can tweak some of these visualizations, and particularly the color schemes, are to use some of the buttons up here in the left hand pane. So there are a couple of ways to color code individual nodes or nodes that are connected to a particular node. So if I wanted to just change the color of a particular node, I can select this sort of pen-looking tool that's directly beneath the dragging tool. And again, if you hover over any one of these buttons, it gives you a little bit of a pop-up box to tell you what it's actually doing. So it'll sort of allow you to see what this tool will actually do. So if I select this particular one, this is going to color code any one particular node that I happen to click on. So if I wanted to just highlight this one particular author, for instance, I could just click on that, and it would give it a red color. Or if I wanted to change the color, I can again click on the box up here at the top, and it will again bring up a dialog box where I could select a different color. I could select some attributes about the color, so on and so forth. So again, I could do that, or if I wanted to undo that, I can go back up to the nodes and then color, and then again just use that grayscale and just recolor it to just a flat gray color to turn that off. Another thing that we might be interested in doing is, in addition to looking at this particular author, we might also want to highlight the authors that that person is connected to. So if we wanted to highlight both the particular author and all of these other authors that are connected to this person, we can do that with a single click. So to do that, we can use this brush attribute, or this brush tool, where it will color both the original person and all of the people that person is connected to. So with that selected, again, if I click on this one person, it will highlight all of the individuals that this person has written at least one paper with. So again, another way of just sort of highlighting individuals, highlighting connections between people, so on and so forth. There are, again, a couple of other options that we can play with in this particular task pane. but those are some of the ones that I might use relatively frequently. Again, I'm going to undo that by just going again to nodes, unique color, and then click on apply to just set it as a flat gray color. So the next thing that we want to do is we want to do some tweaks to this layout, because as you'll notice, once we did that sizing function, we've got a lot of nodes that overlap one another. So a lot of these are just overlapping one another. It's not really a good layout as it is because we want to see each individual node. So to do that, we can actually go back to the layout algorithm, and we can go back to this forced atlas algorithm. And this time we can actually tweak it so that the nodes don't actually overlap one another. So we can actually, within the attributes down here at the bottom, with forced atlas 2 selected, we can actually select the checkbox next to prevent overlap. So it actually has this function built into the actual layout algorithm. So we can click that, and then when we rerun the algorithm, it will run it, and again, you click stop when you're done, it will rerun it so that it keeps the base layout, but now none of the nodes actually overlap one another. So the general way of doing this is you want to run this after you get your initial layout done, because this particular prevent overlap option really slows down the algorithm. So what you want to do is you run the algorithm with all of the defaults first to get the base layout and the arrangement the way that you want it. Then you'll size the nodes and then come back to that prevent overlap feature and then just tweak the layout a little bit just to prevent those nodes from overlapping. Just a best practice that we typically use to actually work with this particular tool. So again, we can also do some additional adjustments if we wanted to, but let's go ahead and move on to the final piece in this overview tab, which is to actually show the node labels. So again, we want to actually see who these authors are and actually adjust them based on those labels. So we want to turn that on, and we do that with this box down here at the bottom. It's this T button. Again, a lot of these things, very common things in this particular tool, are kind of buried in the interface. A lot of the things are really buried in the interface, so you just kind of have to click around and play with things to see what things do. It's unfortunate, but it's just sort of part of working with this particular tool. So I'm going to click on the T, and it's going to be a mess because all of the node labels are all exactly the same size, which makes it very, very difficult to actually see anything but the node labels. So the next thing that we want to do is actually size these node labels based on the size of the node behind it. So the larger the node is, the larger the label size, or the smaller the node, the smaller the label size, so it's much easier to actually see the nodes within this particular network. So to do that, another thing that's really buried in the interface is down here, there is in fact a size mode that we can use next to the label options. So if we click on that size mode, we can either select fixed, scaled, or in most cases you want to select the node size. So that will actually size it proportional to the node size, makes it much more visually interesting to look at. This is still kind of a mess, so we can again sort of clean this up a little bit actually by using some of the options to the right of that node size attribute. If we wanted to, we can click into this Arial Bold 32 option. If we click on that, we actually have a number of options for changing the font, changing the font style, and also the font size. So we can do that here, but most of the time what I do is actually use the slider that's next to it. So what you can do is click and drag on this slider to make things either larger or smaller, depending on what it is you're interested in. This is a much more dynamic way of doing things, and so it gives you much easier control over how big you actually want the node labels to be. I just find this a lot easier to work with node sizes, so that's the way that I typically do this. So again, I'll get it to a size that I like, and then work with it from here. So this looks pretty good from my perspective, so I'm going to go with this. However, again, what you'll notice is a lot of these node labels will overlap one another, particularly if you zoom in and sort of drag around. A lot of these node labels are overlapping one another, so it can make it very, very difficult to actually read any of the actual labels. So the final thing that we want to do here is once we've got these labels sized the way that we want them, we can actually apply a final layout algorithm down here and apply this layout label adjust. So it actually has a layout algorithm designed for doing this. So we can run that. And again, I'll just keep all of the defaults the way that they are, and then click on Run. And again, so it will just tweak the layout such that all of the node labels are not overlapping one another. And this is one of those algorithms that will actually stop when it's done, so you don't have to worry about stopping it. But again, now that we've run that, again, we can zoom in very, very closely here, and again, we can read all of the actual node labels very, very clearly, so we can actually work with this in a final visualization. So at this point, I might do some additional tweaks to this layout if I wanted to, but now I can, for most cases, this is what I would want to go ahead and visualize. Before I do that, though, I wanted to mention some things in this data laboratory pane. So this is most of the things that I would do in the overview pane. Now I'm going to move on to the data laboratory pane. So this data laboratory essentially gives you an Excel-like look at both the nodes and the edges that are actually present in your network. So it actually gives you a list of all of the individual nodes that are actually present in the network. Or again, if you go to the upper right, you can switch this to edges to select, to see all of the attributes about the edges that are present in your network. There's a couple of things that we can actually do here. So I'm going to go back to nodes. And so say we're interested in finding particular authors within this network. We can actually use this data table to be able to actually find those authors. So what we can do is we can go up here to this filter pane, and instead of searching by ID, we can search by label. And then if we start typing in something, say VIB, it will filter the node table directly to whatever author I happen to be searching for. So in this case, I'm interested in this Vibud C. So if we're interested in finding that individual person, we can again filter the node labels or the data table to that one specific person. We can bring up the time cited and the number of authored works and other things about that particular node. We can also click in to the label and adjust it if we wanted to. So if we wanted to double click on this, we can actually bring up a dialog box where if we wanted to change this to maybe CE or something. If we wanted to make adjustments to the labels or the other attributes about a particular person, we can do that in here, and then when we click out, it will save those changes. So again, with any of these, we can just double click on the actual cell and adjust the cell from there. So, and then to stop the filtering, just hit backspace in the filter, and it will go back to your original node table. There are some other things that we can do here. So if we wanted to add, say, a categorical variable to all of our authors to say certain authors are from NIH and other authors are from somewhere else, we can actually do that here in the data table with a couple of additional column operations. So one of the things that we can do is we can just add a column to the entire data set to create this sort of binary attribute of yes, they're from NIH or no, they're not from NIH. So we can just add a column here by clicking on the button down at the bottom. And so we can just give it a name and give it a type. So I'll just call this is NIH, just to call it something. And then I'm going to keep it as an integer because I'm going to have either a 1 for you're from NIH or a 0 if you're not from NIH. Or you could have it as just a string, a double, a Boolean, all kinds of other file types. But again, I'm just going to keep this as an integer and then select OK. So now I've got this new column that I can work with to add attributes to. So the easiest way to do this is to use one of these other operations where we actually fill column with value. So you can actually fill the entire column with one value and then change that value for the ones who are actually from NIH. So what I'm going to do is I'm going to set this to 0 for all of my authors, because the vast majority of my authors are not from NIH. And then I can click in and change those attributes for the people who are from NIH. So I can click on Fill Column with Value, select the particular column that I want to fill. In this case, this is NIH column that I just created, and the value that I want to fill is, again, a 0. So click on OK, and now it'll just fill in zeros for all of the ones that I'm working with. So now if I wanted to then go and find the particular people who are affiliated with NIH, I can again use this filter option to be able to get directly to those people. So I can go filter, label, filter I want to do VIB because I know this person is from NIH. I can then go change this is NIH column to a 1. And again, I can go through this for all of the additional authors that I want to use. So we can go back to label, find another author, Roger Glass, who is also from Fogarty. So we can change that attribute. And again, just go through this for each individual person to change the attributes. Let's do this for one more. This Miller, MA. You can also change to a 1. And again, go through for all of the additional authors and for all of the nodes in my network. So what I can do now is, now that I have this attribute, I can actually color code based on that attribute. So rather than trying to find them and color code them one at a time in the Overview tab, it's much easier to do this in the Data Manager tab and then just color code based on that attribute that I just created. So I can go back to the Overview tab. In this case, I can color code, and I can go to partition now, because I want to color code if it's 1 for one category, a different color for a different category. So I can do color, partition, and then select this new is NIH attribute that I created, and then I get a binary attribute for color coding them. Again, I could click on these boxes and change the colors, but for the purposes of demonstration, I can just go ahead and apply this. And so now it's very, very easy to see who the individual NIH authors are versus the other authors in my network. So this is, again, one of those things that we get asked to do on a fairly regular basis. So this is one of the ways that we might be able to do that for authors in a particular co-authorship network. But for my visualization, this is not actually what I want to do, so I'm going to reset it. So I go back to unique and then apply just that flat gray color for my final visualization. One final note about the Data Laboratory tab is that we can actually export lists of both the nodes and the edges that are present in my network. So again, with this particular co-authorship network, I not only have the number of authored works, but also the time cited for all of the authors in my particular data set. Sometimes this is a very interesting thing to be able to give to customers. Sometimes people are very interested in that. So we can actually export this node list directly from Gephi into a CSV file. So we can just click on Export Table, and it will bring up a CSV file for the particular set of nodes that we happen to be working with. We can export that and use that in other tools, create other visualizations based on that, other types of things like that. So there are some other things that we can do here in the data laboratory, but I'm going to go ahead and move on to the preview pane to actually set the final visualizations of what our co-authorship network is actually going to look like when we export a flat image file. So to do that, we're going to go up here to the Preview tab. And this Preview tab is where we actually set the final visualization settings. So to actually get a preview of what the network is going to look like when we export it, we actually have to go down here to the bottom left here and click on Refresh. So that's going to give us a look at what our visualization is going to look like if we just exported it right now. Very, very strangely, you can see that some of the things that we did in the overview tab are present and some of the things aren't. I have no idea why this is the case, but it's just the case that in Gephi, we actually have to redo some of the things that we did in the overview tab here in the preview tab. It's just one of those quirks of working with a particular tool. You actually have to tell it to actually visualize some of the things that we did in the overview tab. It's just the way it works. So to do that, we're going to go up here to these preview settings, and we're going to reset some of those settings in these previous settings to actually get them into our network. So we want to get the edge colors that we set. We want to see the node labels. We want them sized based on the node sizes. We want all of those other things present in our visualization. So the first thing we're going to do is we're going to work with the edges to get the colors and the sizes right. So we can go down here, and within the previous settings, we've got these settings tab. And this is what I always work with. And there are categories for nodes, node labels, edges, edge labels, and so on. So to work with the edges, I'm going to go over here to edges. And under color, you can see that it's currently set at mixed. So essentially, it's a mixture of the color of the two nodes that at the edge is connecting. So in this case, because both of the edges are gray, all of the nodes are gray, all of the edges are gray. So to change that, we actually need to click on this dot, dot, dot box that appears next to the particular setting. And so for all of these settings that you can actually adjust, there is in fact a dot, dot, dot box. So if you click on that, that will bring up ways that you can actually set those previous settings to actually get them to what we want. So under edge color, we're going to select this box here, and that's going to bring up a dialog box. So we can either set it to mixture, we can set it to a custom color if we wanted to, but in this case we're going to select the original color, which is the color that we actually set over on the overview tab. I don't know again why we have to redo that, but that's the way that we have to do it. So we can click on OK, and then if we refresh, now we actually see the colors that we actually set in the overview tab. From my perspective, though, some of these edges are still a little bit big. They're a little bit too wide for what I would like to see in my final visualization. So I'm going to actually reduce the overall size of these things to make it a little bit easier to see some of these stronger connections within the weaker connections. So I'm going to set the thickness of the edges here. I'm going to reduce it from 1.0 down to 0.5. And then when I click on refresh, makes them just a little bit smaller, makes them a little bit easier to see. Some other tweaks that I'm going to work with are I'm going to actually work with the node labels here. So to actually have the labels show in the final visualization, I can click the little checkbox here to actually show those labels. So if I refresh it now, it will actually show the labels, but again, they're much too large for what we want, so we need to reset them to make them into something that looks a little bit more manageable. So again, I'm going to click on the dot, dot, dot box, and I'm going to select now the label size. I'm going to reduce that size all the way down to a font 5. And so it's going to scale around that font 5 rather than font 12. So I'm going to click on OK, and then refresh. And so now they're a little bit more reasonably sized. Again, they're still a little bit close together here, so it's a little bit difficult to see. So what I can actually do here is once I get a sense for what the final visualization is looking like, I can actually tweak the layout a little bit to make it work a little bit more effectively. So in this case, what I'll do is I'll actually go back over to the overview tab. And now because some of these things are still a little bit close together, I'm just going to run this expansion algorithm once, and I'm going to again set it to 1.2, just to expand everything a little bit so that things are a little bit further away from one another, so that when I go back to the preview tab and hit refresh, it's a little bit easier to see. So they're not quite so crowded together. It's a little bit easier to see in the final visualization. So since I've changed the the view now, I can actually go down here to reset the zoom to actually see what the full network is going to look like. This is a lot better than it was previously, so this is probably what I'll go with. The final tweak that I'll make is to actually remove these sort of black lines around all of the edges. This is kind of a personal call. You can remove them or you can keep them in. I just happen to think it looks a little bit nicer without them. So I'm going to go up here to settings, and then instead of border color, again, I'm going to click on the box next to it. And instead of this custom color that it's currently set to, I'm going to set it to parent. So it's going to be whatever, that line around it is going to be whatever the color, the original node color was. So in this case, it's going to be that nice gray color. So I'm going to click on OK, and then refresh. And now you can see the lines are gone. I just happen to think this looks a little bit nicer. So this is what I will typically go with. So now that I've got this to what I would actually want to visualize and create as a static image, now I can actually go ahead and export an image. So to do that, again, I can go down here to the very bottom left and click on this button that says Export SV or PDF or PNG format. So if I click on that, it again brings up a dialog box where I can save it to a particular file location, and then you can change the file type to be either SVG, PDF, or PNG. If you want to just drop this directly into a Word document, a PowerPoint, or something like that, you'll probably want to select a PNG file, and because that way you can just drop it right into a document and go from there. However, these kinds of file formats can get somewhat pixelated if you zoom in at higher levels. So if you wanted to really zoom in and look at these things, you'll want to use a different file format. If you want to really get in and work with the tool, the PDF option is a great export format for doing that. If you export it directly to a PDF, it actually saves it as a different file format. So rather than being what's called a bitmap image, it will actually save it as a vector image. And so that way, you can actually zoom in all the way into that PDF, and it will never actually pixelate. I'll talk a little bit more about what these actual file formats are in the next session, but just as an FYI, if you want to get in detail, that PDF option is great. Also, if you've got Adobe Illustrator and you can edit PDF files directly, that's a great option also for doing some other things. But for the purposes of what we're going to do in the next course, what we actually want to select is this .svg file format. So this SVG stands for Scalable Vector Graphic Format. So again, it's like a vector graphic software, or it's like a vector graphic like PDF, but it's more universally readable. So you can actually read it into other things beyond just Adobe products. So we're actually going to use this SVG file format to work with it in Inkscape a little bit later on in the next course to do some additional cleanup. We're going to add a legend to this. We're going to do some other things before we export the final image. So again, we don't necessarily have an image in this, or we don't have a legend in this image yet, so we'll need to do that somewhere else. We typically tend to do that in Inkscape, so we'll again save it to this .svg file format to then work with it in Inkscape to do some of that cleanup. And again, once you're done with all of this, if you want to go back to this particular visualization and save all the settings, you again want to do that file save the project as a .gephi file, so you have all of the layout, the sizing, the coloring, all of that stuff available to you so you can get back to it. So that's the basic workflow for working with a co-authorship network. So just in the interest of time, I'm going to also run through how to actually create a similar kind of visualization in an institutional co-authorship network. I'm going to work a little bit more quickly through this just to give you an idea of what this looks like. Again, you can pause it and rewatch versions of it at any point along the way, so feel free to do that. In this case, I'm just going to go ahead and close it and not save changes. So now I'm going to work with, again, that institutional co-authorship network and just sort of, again, run through this entire process again, just so you see what it looks like, and also how to tweak it for this different kind of a collaboration network. So again, I'm going to go to Visualization, Networks, and then Gephi with that particular network file selected in my data manager. So again, it will give me an import report. I can mostly just ignore it and then just click on OK to start working within the actual tool itself. So I'm going to go to the Overview tab. And so this case, the network looks a little different, but again, it's just a random layout. It's just a very different size of a network that I'm working with. Far fewer nodes, far fewer edges. So again, the first thing that I want to do is apply a layout algorithm. So in this case, I'm actually going to choose Force Atlas Plain rather than Force Atlas 2. And this is because I've got some very, very strong co-authorship structures. And so the Force Atlas algorithm is a lot better at handling that than the Force Atlas 2 algorithm. So I'm going to run this as it is. And it ends up being this nice odd little dot in the middle of the screen. So I'm going to stop that. And this is, again, because of those very, very strong edge weights. So those very, very high weights within the edges are throwing this algorithm off, and it's clumping everything together in a very, very tight space because everything is very tightly connected. So to change that, we're actually going to tweak this settings a little bit. So instead of running the Force Atlas algorithm as it is, we're going to change the attraction strength. So instead of putting it at a strength 10, we're going to reduce this all the way to 0.1. However, when I actually go in here and try and start typing, it doesn't actually let me type. This is a bug in the interface. It happens all the time. Don't worry about it. The way to fix it is to go over to the Data Laboratory tab, let it sort of adjust itself, go back to the Overview tab, and then click in and start typing, and it starts to work. I don't know why this works. I don't know why this happens. This is just a bug in the interface. You just work with it, and you just go with it. So I'm going to run it that way. And so now it looks a little bit more laid out, a little bit more intelligently. I might even reduce this even more, maybe go to 0.05, try that. Not a whole lot of difference, but again, you can kind of tweak it around, play with it, see what makes it work, and then go with that. So I'm going to zoom in, get this network actually centered in my visualization pane here, and start applying some of the individual attributes. So first thing, again, I'm going to set the color to be a flat gray color. Then I'm going to size the nodes again based on the number of works. So nodes size, and then to ranking. And in the drop-down box, again, I'm going to select this number of works. I'm going to use this 5 to 50 again. We'll just see what it looks like, and then click on Apply. So this actually turned out pretty well. So this is not bad. So this might be what I'll actually end up going with. It's maybe still a little bit tightly connected or tightly laid out. So I may actually just run an expansion on it, maybe twice, just to kind of get it to where I want, and then go with it like this. This looks pretty good. So we'll go with this. Then I'm going to go up to the edges and color code the edges based on the number of works. So I select edges, ranking, and then select co-authorships. And again, I can either use this green gradient or reselect that particular blue color scheme that I use all the time. Click on Apply. And so it's very easy, again, to start seeing where the strong collaboration structures are. So from here, the next thing I want to do is show the node labels, and then change the label size to node size. So this starts to get to something that's a little bit more meaningful looking. Again, I can toggle the slider to change the actual size. Maybe I'll go with something maybe like that. Zoom in again, maybe a little bit larger. And then, again, run the label adjust algorithm so things aren't overlapping one another. And so now we're just about good to go for visualizing this particular network. So again, I'll go over to the Preview tab, click on Refresh, and again, we've got this whole big mess because we've got these very, very high edge weights. So these lines are very, very thick because there's so many co-authored works. So again, we want to reduce the edge thickness. This time, again, instead of 1.0, I'm going to go all the way down to 0.1. And then again, with the color, I'm going to change to the original edge color. Click on OK, click on Refresh, see what it looks like. This is pretty good. So I might play with what 0.2 might look like. And that's too thick. So go back down to 0.1, refresh, and we'll good to go. Then we'll go with this. So now again, we'll turn the node labels on. We'll change the node size. In this case, I might go down all the way to 3 because we've got a really, really large node here. So let's see what 3 looks like. Click on OK, refresh, and that's actually too small. So we can actually go back up here to font, maybe move it up to 5, see what that looks like. Still overlapping a little bit, so I might want to actually go back over to the Overview tab, readjust the settings, rerun the label adjust, and come back, other things like that. So that, again, kind of tweak it just to make sure that everything looks the way that we want it. The other things that I might do here is I might adjust some of the positions of the individual nodes here because some of the lines are sort of overlapping one another. It can be a little bit difficult to see which one is Johns Hopkins versus Penn State, for instance. So I might sort of tweak where these things are a little bit manually just to adjust some of those things and make any other final tweaks that I want to do. And again, turn the border color to parent, refresh, and then once I got it to where I wanted it, then I can go again and export this particular diagram in an SVG file format that I can then work with in Inkscape. So again, just very quickly wanted to sort of run through the process again, just to sort of reinforce the overall workflow, give you a sense of what this looks like for a different kind of co-authorship network, and go from there. Again, with both of these kinds of networks, though, you will want to go over to the data laboratory and export the table. You'll want to have these lists of both the nodes and edges, because if you're going to go in to create a legend later on, you need to know what the sizes are, what the sizes represent, and what the edges are to be able to actually visually represent what or how many co-authored works this very, very strong blue line is versus one of these smaller lines and some of the smaller lines like that. So you want to have lists of both the nodes and the edges for both the individual level co-authorship network and the institutional level co-authorship network to be able to build those legends so that you can actually represent the visual structure that's actually present in your visualization. So you, again, want to have all of those lists available to you in addition to that SVG file format to then go in and actually work with the settings and work with it in Inkscape later on. So that's where we're going to pick up with the next lesson. So again, we just wanted to sort of work through a number of the settings that are available in the Gephi interface. And then once we move into the next lesson, we'll talk about how to actually work with the images that we create here to make them into something that I would actually put in a report or a publication.